Hello everyone, welcome to another video. Today I'm going to be working on this PlayStation 5. This has been sent in by a customer, and this customer has originally sent this to none other than CEX. For those of you that don't know, CEX is a electronics repair store and franchise in the UK, and apparently they offer repairs on all games consoles and mobile phones. But one of the issues that I have is that customers will get in touch with me saying they've sent it there, and then they'll get a message back from CEX saying that they don't offer board level repairs. So not only are they wasting the customer's time, but they're also wasting their own time. So yeah, that's one of the gripes that I have with CEX. It's sort of like GameStop in the US, for those of you that are not familiar with it. But basically, they don't offer any board level repairs at all. And the stuff that they do offer, I've had people send it back to me or send it to me when it's come from them because they've messed it up, and then they've tried to blame it on something completely different. So obviously I'm just going on what customers tell me and stuff like that. I never know the whole story, but that's what customers tell me. But this has definitely been to CEX, and I know it's been to CEX. I've got to be careful here because there's a customer name on it. But it's got the good old unrepaired sticker on it, and then it's got the Tech Centre, JB154633 Sheffield. So that's where this has been. That is the Tech Centre that CEX used, and they apparently don't offer board level repair. So yeah, this apparently doesn't turn on anyway. For those of you that don't know me, my name is Hakko. I'm an electronics technician who actually does offer board level repairs. So if that's the sort of stuff you're into, be sure to get subscribed and turn on the bell notifications, and that way you won't miss any future videos. Turns out around about 60% of the viewers who watch these videos are not subscribed, so I do really appreciate people watching the videos. But if you could just hit the subscribe button, it would let me know that you enjoy the videos and that you want to see more. It does help to keep me going. And also, if you do want to organise a repair, you can get in touch at www.thecoder.repair. The code is spelled the same way as here on YouTube. If you need any parts and supplies for these, you can buy those on my online store. You can go to consolefix.shop. All of the links are in the video description, and all of the links to all of the tools and stuff that I use for these repairs are also in the video description as well. So with that being said, let's get into today's video. Okay, so like I said, this has got the old unrepaired sticker on it, which is typical when it comes from CEX. It comes in these plastic bags with customer information on them and stuff. I mean, at least they take care of them when sending them back, I guess. But apparently these consoles don't turn on. But like I said, one of the issues I have with CEX is the fact that they don't actually offer the board level repairs, and they claim that they do. So it's false advertising. But yeah, anyway, here's the sticker. I've got to cover the customer's name, obviously. But there's the sticker with the CEX information on it, or the CEX Repair Centre. So they've been inside this by the look of it. They haven't stuck that back down properly. That's annoying. So yeah, let's have a look. So I'm going to pop the power supply in. Okay, we get no sign of life at all from this. So that's a good thing, to be honest. So when we get a 2-second beep, 2-second blue light of death, for example, that could be pretty much anything. There are tools that we can use to help us with that, but it could be pretty much anything. But when it's completely no power, it's usually down to a short on the board, so that is a good thing. It's usually fairly straightforward to find. Okay, we do get a beep after about 30 seconds. Alright, so it's a single beep after 30 seconds. Right, gotcha. So, I'm going to get this apart. I'll skip through this bit. But let me know, have you ever dealt with CEX in the past? In terms of, for repairs and stuff, did they actually repair the device that you sent in? Let me know, because I've never known a successful repair from CEX. Of course, as many people will know, a lot of the PS5s that come through my door end up being fixable. So that's not me bragging, it's just the truth. Okay, and there we go. So that is all the screws removed. The one thing that really annoys me is, look at this. Like, why break those stickers? Just drop a little bit of isopropyl alcohol on it and it'll just peel up. Like, why break it and cause it to have to either be replaced or sit there without one. Same as these foam covers as well. Like, there's no need for it. But anyway, let's get into it, shall we? So the first thing I'm going to do then is I'm going to test for some voltage rails on this. So when you first apply power to the console, it will go through a sequence of initializations where it will turn on certain rails, certain power rails. So for example, for the console to start up successfully, it needs a 5-volt rail, it needs a 3.3 volt rail, it needs a 2.5 volt, 2 volt, 1.8 volt, 1.2 volt, 1.1 volt and 0.8 volt. So there's like 9 different voltage rails roughly that it needs before it will even attempt to power on. So what we can do, some of those we can check and see if they're present before the console is on, while it's in standby. So there's certain rails which it's going to need for it to even attempt to power on. So let's look at those. So I'm going to take the multimeter in voltage mode and I'm just going to check a few of these rails. So given the fact that I've worked on so many of these, you know, I've worked on absolutely hundreds of these, just as I zoom in here, hundreds upon hundreds of these I've worked on, and over time I've got to know where the rails are supposed to be. So just here we're supposed to get a 5-volt rail, and we do get that. We're supposed to get a 3.3 here, and we do get that. We're supposed to get a 5-volt rail just here on F7002, and that is not present. We're getting 0.68 volts on that 5-volt rail. So 0.68 volts tells me that that fuse right there is bad. So what's going to happen is when a fuse goes bad, it's going to increase resistance. It's supposed to be 0 resistance, 0 ohms. That's how a fuse works. It's just a wire, and it's a wire that's designed for a certain amount of power to go through it. So if the fuse goes bad, the resistance is going to increase as the fuse starts to blow open, if that makes sense. So as the resistance starts to increase, the voltage which is going through it is going to drop. And right now we're getting 0.68 volts, which obviously is no good. We're supposed to get a 5-volt rail here. So if I just test the right hand side of the fuse, we are getting 5 volts on the right hand side of the fuse, but on the left hand side of the fuse, 0.68 volts. So that fuse is 100% bad. Now, the problem with that, I mean, we could replace the fuse, but the issue with that is the fact that a fuse doesn't just go bad. It doesn't just blow for no reason, right? There's obviously a reason why that fuse has blown, and that reason is likely going to be a shorted component somewhere, likely a shorted capacitor, or in some cases one of the ICs. In this case, F7002, when that goes bad, when that goes short, typically it's going to be down to one single bad capacitor, and that is what causes it to blow. So let's get the rest of this apart then. I'll get the board out. I don't need to go any further because we haven't got the 5-volt rail coming through here, which means we haven't got the 1.8 volt rail here. So we may as well just take the board out of the housing and just try and figure out why this fuse has blown. We don't just want to go replacing the fuse because it will just blow again. So we find out why the fuse has blown, we relieve that short, and then we replace the fuse. Now, F7002, one of the issues with that is that area does go to quite a few different spots. This is the EDM020 board, so it's not the SBV chip, it's a different chip. I do sell them on the online store if you do need them, and the fuses to go with it. So what I'm going to do is I'm going to inject voltage into this fuse here and try and find out why it's blown. In the easiest way I can explain voltage injection, we're going to force power to go through the circuit which is bad, because electricity is always going to want to take the path with the least resistance. The path with the least resistance is going to be a shorted component. So we'll be able to pick that up with a thermal camera because the electricity will all be flowing through that one component. It'll get really, really hot, or it should get really, really hot, and then we can pick it up with the thermal camera. I'll leave a link to this in the top pinned comment because this is an absolutely fantastic thermal camera. I've said it before, this isn't sponsored. I did receive this for free, but it's not sponsored, but it is an absolutely fantastic camera. I've been using it for well over a year now, and I have never had an issue with it. So yeah, let's get that set up. And as you'll see here, we've got this area, F7002. So F7002, this area in particular, it takes 5 volts in. So 5 volts comes from elsewhere on the board, and it goes through this fuse here, and then it goes up to here. It goes into this little chip just here, and then that outputs 1.8 volts here. So what we can do is we can just check and see if any of this is actually short. So I've got the multimeter in continuity mode. So that mode is going to beep when we complete a circuit. We can actually see a hole in this fuse here, right? So we know that this fuse is bad. I'm testing that and it's just open line. So in continuity mode then, do we have a short on the right hand side? We do not. Do we have a short on the left hand side? We don't. Interestingly, okay, that's very odd. So has this fuse blown for no reason? That's very strange. That's not normal for F7002 to just blow for no reason. It can. I mean, we've got a very significant hole inside in the actual component itself, so it can blow for no reason. But why? How? Very, very odd. I am going to try replacing the fuse and just see if it powers on, because at the end of the day, I'm not seeing a short on that circuit. I'm going to check a few more circuits first, a few more of the 5 volt areas, just to see if we've got a short anywhere else. So there's a 5 volt circuit here, F7001, just in the top left corner. That fuse is absolutely fine, and it's not short to ground. Do we have any shorts on this 3219A? We do not. Okay. What about on the HDMI encoder then? F7002 does power the encoder as far as I'm aware. Or rather the 1.8 volt side of it does. I'll just check this area just for shorts, and we don't have any. What about this magnetics module? We shouldn't hear any shorts on this, and we don't. 5 volt for USB is absolutely fine. Okay. What about the... Okay, someone's actually done some work to this. This isn't factory. Someone's actually attempted a repair on this, on the Wi-Fi. Okay, we have a short here. No, we do not. It's giving me a false reading. Never mind. Right, okay, so that's fine. Someone has actually attempted a repair here. You can see here that this has had some replacement capacitors. Why, I do not know. But whether that was CEX is a different question. Okay, that's absolutely fine. That's fine. We have no shorts around here. What about here? So this is one of those SBV chips I was talking about. No shorts. Okay. About F3501. That's fine. F3502 is fine. And we have no shorts as well. F7001 is fine. And we have no shorts. And this bank of caps here, we have no shorts as well. Okay, so it really does look like it's just a blown fuse. Let's remove that fuse. Okay, that's actually stuck itself to the board. It's kind of welded itself to the board there. Took 480 degrees Celsius just to remove that. Interesting. That was very oxidized. That was very, very oxidized. That was strange. Okay, so I'm going to take a replacement fuse off a board. Save me pulling a brand new one out. I do have some brand new ones, but I usually like to keep those for stock on the online store anyway. Okay, let's drop this on the board. And there we go. I'm just going to clean up this little bit of flux with isopropyl alcohol. And I'm honestly not happy with that solder joint. I take pride in my work. That's better. I did just catch that F7002 marking with a little bit of solder. And there we go. Good stuff. So what's the situation now? Do we still get... There we go. Okay. So we've got continuity and we've got no short either side of it. We should be good to go. So I'm rather confused here because the capacitors around the Wi-Fi IC, or the back of the Wi-Fi IC, so just here, have had some prior repair attempts. Someone's obviously replaced some of the components, but yeah, that don't make sense because they've replaced the components, fine. Why didn't they replace the fuse? If it was CEX and they've replaced those components, if they have magically found that short, which I find hard to believe with CEX to be honest, but if they have found a short on these capacitors, how did they not find that? The amount of times that I've put out about F7002 blowing, it's unreal. A quick Google search would have come up with something to point them in the right direction. And we have UART, Universal Asynchronous Receiver and Transmitter. It would have told them F7002 had blown. But hey ho, it is what it is. Such is life and all of that. Let's get this tested. Pop that there. I do need to sort out liquid metal and stuff like that, but I can do that off camera. Okay, you ready? 2-second blood. Oh no. Okay, so now we have a 2-second blood. So now we do need to connect up to UART. So if we take a look around where the LED ribbon connector is, we've got 10 little test pads here. And this is where we can connect to UART, so as we can basically connect it up to the PC and do some tests. The only 3 pads we need are the ones that I've just put flux on. So I'm just going to first of all tin this up with some fresh leaded solder. And the pins that we need, ground is going to be the very far left pin, just here. Let's just solder that to there. There we go. And then we've got TX and RX. So TX on my reader is going to be the brown wire. That's got to go to RX on the board. And RX on the board is this bottom right one. And then TX on the board has got to go to RX on my receiver, which is the white wire. So if we just take a look here, the white wire, RX, brown wire, TX, and then black for ground, obviously. There we go. So that's all connected. Now I can connect this up to the PC and we can get some error codes. So I've got my USB Type-C cable. Connect that up. There we go. And then I want to just apply power to the console itself. And then we'll go on to the desktop. So loading up the UART software then. This is completely free. This is designed by me. It's coded by me. And you can download it for free on GitHub. But if we just click on get error codes from PS5. And then I'm going to choose option 5 for COM port 19. And okay, so we've got 80810001 and C00C0303. That's general power failures. And then we've got a Wi-Fi Bluetooth power failure. Okay, so let's clear the error codes. Done. And now I'm going to reset power. Okay, and now I'm going to read the error codes again. And we just get general power failure. Right, okay, so we did get a Wi-Fi error on this. So it does stand a chance that Wi-Fi could be the cause. I'm not seeing any heat from that. Okay, let's just check some power rails. See what power rails we have now. So do we have our 5V back on the left side of F7002? We do. And 1.8 volts, yes. So we've got 1.8 volts back. Let's just check for 1.1 volt. We do get that. We get 5 volts there, 2 volts there, 0.8 volts for the APU, 1.2 volts, 2.5 volts. We do not get a 5 volt rail here. Yes, we do. Never mind. Ignore that. Okay, so all of those power rails appear to be there. So, I mean, this is a tough one because we've had some prior repair attempts around the Wi-Fi IC. Now, the fact that F7002 blew tells me that it could very well have been an issue with Wi-Fi. Because F7002, not only does it power the HDMI circuit, but it also powers the Wi-Fi circuit as well. So it could be that something's ended up blowing on the Wi-Fi IC, and that's possibly caused the, the fuse to blow before any further damage got done to the chip. But the chip still failed, if that makes sense. So I think the best course of action here is probably going to be to replace the Wi-Fi IC, just given the the fact that it's had prior repair attempts on that area, and also the fact that the F7002 fuse blew as well, and the fact that we do get an error. Well, we did get a Wi-Fi error code on there as well. So the easiest way I've found to remove the Wi-Fi IC would be to heat up from this side of the board underneath, and then just pick it up with some tweezers. Let the heat transfer through rather than risking damaging this connector here and these two antenna connectors, as well as the LED ribbon connector as well. So what I'll do is I'll just set my hot air up to 440 degrees Celsius, 40% airflow, and just heat up from underneath the board. And I'm just going to heat up. My camera was out of line there, I didn't realise until it was too late. Well, hopefully that's a bit better. But I'm just going to heat up this area. I can see the flux is starting to bubble. Doesn't take much for the heat to transfer through. These boards are not incredibly thick, but it is, in my opinion, the safest way to remove it. That's been removed before. Yeah, that's not lead-free solder. So take a look at this solder. You'll see the difference in a minute when I remove one from a donor board, but take a look at this solder. That isn't lead-free, okay? That is not lead-free. That is 100% leaded solder. So this has been replaced before. So has it been replaced with a bad one? Very possible. So if I wick this away now, without adding fresh solder, we're probably going to find it's going to wick away just fine. Maybe not. I could be wrong actually. That just doesn't look like leaded solder to me though. It does seem to take a bit of heat. But then again, I do have a problem by the look of it with my soldering iron tip. It looks like it's pretty oxidized here. I could be wrong here. It could be lead-free solder, but my tip is oxidized, but it just looks too shiny to be lead-free. No, I think that's just my tip. I think this is leaded solder and someone's replaced it. Alright, never mind anyway, it doesn't matter. Let's just replace it ourselves. So I'm going to grab one from a donor board. So exactly the same process then. I'm going to remove this one by heating up from underneath. Not that I care about the connectors on this donor board, but I just want to make sure I don't damage the actual chip. But you'll see the difference in how this one will come off. And I've put roughly the same amount of flux on it as well. So first of all, it's taking a lot longer to come up on this one. I'm just going to wait for this to cool down a bit before I put it down. There's actually an entire ecosystem of components underneath this metal shield, so you've got to be very, very careful when removing them. Okay, so there's my donor board. But take a look at how that one got removed. Look at how dull the solder is on that. You can normally tell the difference between leaded and lead-free. If we take a look at the board itself, again, that looks like lead-free to me. The solder that was on here doesn't. So here's a comparison. Here's the old one. Yeah, that's a reballed chip, 100%. Definitely a reballed chip. It's too shiny to not be. Never mind. We're going to reball this one that we're working with here. I am going to need to tin this. Okay. There we go. Let's clean up. Okie dokie. Good stuff. Add a little bit of flux. Not much, just a little bit. So they say there's no such thing as too much flux. There really is when it comes to reballing. So what I'm going to do then is I'm going to grab some 0.65mm solder balls. I'm going to drop a bunch of them on there. And then I'm going to add 2 of these 0.65mm balls to each pad. The reason I add 2 is because if you take a look, one ball is a bit too small. So even though it doesn't make much of a difference what size the solder balls are as long as they're all even, I do still like to, whenever possible, get them with as much surface area covered as possible. So I add 2 to it and just flow it all down together and it forms into one larger ball. Obviously the two 0.65mm balls end up forming into one 1.3mm ball. But for the most part, you can just use a single 0.76mm ball. Fortunately, there are no stencils available for these, as far as I'm aware. But obviously, I'm going to fast forward through this and I'll pick it up when I am ready to flow these solder balls down. But ultimately, all I'm doing is just adding 2 solder balls to each pad, so as we've got nice, even pads. People have asked me in the past as well, before I start fast forwarding, people have asked me in the past as well, can't you just run the iron over? You can. But the chances of you getting consistent balls is very, very slim. And the one thing with any BGA chip that you really need is consistency. Okie dokie, so that's all prepared and ready. So I'm going to drop my airflow right the way down to 10% now. And if I just come in very, very slowly with the hot air, I'm going to flow these solder balls down into place. They won't merge straight away, but they will merge when I add some more flux to them. Actually, they probably will merge straight away, to be honest. Yeah, so they are merging, but they're just not forming into balls at the minute. Okay, there they are. Okay, there we go. So I just need to add a little bit more flux now, so I'm going to wait for this to cool down. Just wait for the solder to solidify, and then just add some flux. I'll pop my airflow up to 40% now. Let's hold the chip in place, or roughly, and just flow them until it's all molten. And you should be left with perfectly round, fluffy solder balls. Beautiful. Alright, we don't need any more flux than what's already on the chip there. So if we just take a look at the board here, you'll see that there's a pin missing here, and there's one missing on the board. So if we just invert that, it'll line up nicely, and then just drop it into place. There are some guidelines for this chip, so it's fine. And now we're going to heat up. So I will heat up from this side of the board, just because it's too awkward to solder the chip from underneath. But it won't take long to actually flow anyway. Okay. So notice I gave that a tap there just to make sure it sprung back into place. Now I'm just going to add some more flux. I'm going to solder it once more. So the reason I don't add flux straight away is just because I don't want it to float off everywhere. There we go, that's good. So yes, the metal frame is going to be a little bit burnt. That's absolutely fine. It does protect the components underneath. And there we go. So that is all done. I'm going to wait for this to cool down, but while I'm waiting, I'm going to put it back in the housing. Let's pop this together. And I'm just going to give it a little bit of a clean up. Now that it's cooled down a bit. Just get rid of any excess flux around here. Doesn't matter about a little bit of isopropyl alcohol getting inside the housing. And yes, like I say, the shield is going to be a little bit burnt up, you know, a little bit brown. But that's perfectly normal, it's fine. It's just a heat shield. And that is it. Well, heat and EMI. Okay, let's have a look. Is it going to turn on now? Oh. Right, well, unfortunately, I don't know what else this could be then. I mean, I'm getting all of my voltage rails. The fuse for F7002 had blown, and the Wi-Fi IC had been messed with, as well as the capacitors on the back. Did someone change the Wi-Fi IC because they'd found a short there, or did they change the Wi-Fi IC and knock some components around the back, and that's why they've been changed? I honestly don't know what else to try. I do need to contact the customer and try and find out if any other repairs have been attempted on this, because, well, at the minute it's not looking good, is it? So, yeah, the problem with the 8081001 error code, as well as it's a generic error code, it doesn't tell us exactly what's wrong. It just says that one of the chips somewhere on the board has failed. And unfortunately, it's not really economical to be going around changing every single chip, is it? Especially when we're getting all of the voltage rails that we should be getting for it to turn on as well. But it is what it is, you know, it's one of those things sometimes. So sorry this is going to be a no fix. We at least got it to sort of turn on, I guess. But hey, yeah, it's one of those things. I do have a EDM020 board with the disk drive board, which I can use to do a part exchange with the customer if needed. So I'll call the customer, I'll see what they want to do, and if I get some more time, I'll try and work on this again. But I've been working on this for an hour and a half now, and I can't really spend any more time on it at the minute. So with that being said, thank you very much for watching. I really do appreciate it. If you do have any comments or questions, let me know down in the comment section down below. I do always read comments. I don't always get to reply to them all. You know, I do a lot of things during the day, and at night, to be honest, I don't really look at my phone that much. But yeah, I do always read comments anyway. So leave me a comment, let me know what you think. And if I can, I'll reply, or if I feel like it warrants a reply, then I'll reply. If you do want to organise a repair, you can get in touch at thecodat.repair. And if you do need parts and supplies, such as the Wi-Fi ICs, the fuses, all of that stuff, consolefix.shop. So with that being said, thank you very much for watching, and I'll see you all in the next video. Take care, everyone. Bye for now.